Hello, I'm Asmus with the Rotochopper Customer Support Team. In this Rotochopper University video, I'm going to show you how to install main rotor bearings on a MC, EC, or MP2 style Rotochopper grinder. The reasons you may need to change them bearings would be if they're failed, pitted, or from an impact causing damage to that bearing itself. If you still need to remove your rotor bearings, please refer to Remove Rotor Bearings video first. The PPE that would be needed for this task: safety glasses, ear protection, gloves, and safety boots. Remember, before starting any maintenance or repairs on your Rotochopper grinder, follow all lockout tagout procedures per your manual. You would have to make sure the machine in the area is safe. As you can see, we have the rotor out of the machine for this example. Tools that will be needed for this task would be a hammer, some memory cloth, flat screwdriver, feeler gauges, chisel, some brake cleaner, penetrating oil of some sort, and then this bearing will take 2 tubes of grease. We have 2 types that can be used: a mobile SHC 100, and also we follow an alternative that's a Talon NLG grade 2 grease. And of course, your main rotor bearing. Now we are ready to start our task of installing a bearing. Now that we have the grease off the rotor shaft, now we can clean it with some emery cloth to make sure there's no burrs on the shaft. Now that the rotor shaft is prepped, we can unpack our bearing and get ready for install. We have our sleeve nut and washer, our main bearing cap, 2 LER rings, our main rotor bearing. This would be a locking ring or an expansion ring. And the bottom of our main bearing housing. So we'll start the process with the sleeve nut and washer. We'll remove this nut. Washer. And we'll slide the taper inside of the bearing. The sleeve will only slide in the bearing completely one way. Now we can install the washer. This washer can only be put on one way with these tabs facing out, away from the bearing. Same thing with this nut. As you can see, there's a chamfer on this nut that has to go towards that washer. Screw that onto the sleeve, just a couple of threads, and leave it loose. Now we can apply some penetrating oil on this sleeve, and we'll put it on all surfaces that will contact the rotor shaft. Now that the bearing and sleeve nut, all surfaces that will contact the rotor shaft, we can set that in the housing and get it ready for install. Before we put the bearing and housing on, we have to put our seals, or LER rings. We'll lube that up as well as far as the rotor shaft. We're going to put grease inside these grooves. The reason for that is that's what keeps the dust out of the bearing itself. So I'll take a little bit of SHC 100 and we'll put that in these grooves on this seal. Now that we have some grease in there, we can set that one in the housing and grab the second one. Now that the second one is greased, we can install that in the housing, and we're ready to slide this onto the rotor shaft. Okay, now that we have all the components installed into the bearing housing itself, before we slide this on the shaft, we always have the nut of this sleeve nut is facing away or out from the machine. Now we can take it and slide it on. And when you're sliding that bearing onto the shaft, you want to try and get it roughly where it was before. Now that the rotor bearing is installed on the shaft, if you're using a jack to lift the rotor up, now we can lower it down onto the bearing itself. Once the jack is out of the way, we would want to make sure the rotor is centered in the case. I would go inside the grinding chamber make sure there's equal gap on both sides. We're going to do that multiple times. You always want to make sure the rotor is centered. For your main bearings, this is an idle side of the machine. When installing that bearing, we'd want to have spacing on each side of this idle side bearing. That is our expansion. If you're on the drive side of the rotor, that would include this expansion ring. That is what locks that down and keeps your drive belts aligned without having any movement. If you were on the drive side of the machine, you would have this slid over. So you can install this expansion ring. It should look about like that when we're done with it. Again, since we're on the idle side of the machine, I have this moved and I have the gap centered on the housing itself. Make very sure that the rotor is centered inside of the machine. Now that we have that done, all of those items, we can start tightening this bearing down to the shaft. So we're going to spin this nut until there's a little bit of pressure. We can use a spanner wrench or you can use a hammer and chisel. I prefer to use a hammer and chisel, and we want to set that onto the shaft. This bearing has a tolerance we want to get it down to is 3/1000ths with the feeler gauge. So now I'm going to set the bearing onto the shaft. You're going to keep tightening this nut until you hear a sound where it's solid and it almost sounds like you're pounding on steel with the hammer. If you have a second pair of hands, you can always have somebody spin the rotor while you're trying to lock down the nut onto the shaft. You can hear the tone starting to change when I'm hitting that nut. That's what I want to hear. That's the sound I'm looking for. Now we can spin that rotor a few times. Usually it's about 20 to 30 times we'd end up spinning that rotor. What we're trying to do at this point is we want to get everything seated in place. Now that we have everything, we've spun the rotor, I'm going to make sure that we're tight enough on this nut. So it didn't loosen up too much. It's pretty tight. I can take my feeler gauge and do a measurement. When sliding this in, the rollers are not directly across. They're at about a 45. So when we slide the feeler gauge in, we want to go at a 45 on that between the roller and the outer race. Do not roll the rotor with the feeler gauge in here. So what I'm looking for is about 10 o'clock and 2 o'clock, if you think of a clock on here, positions to where I can feel tension on the feeler gauge. And there's a little bit here, but it's pretty loose on the other side. So I'm going to tighten this down just a little bit more. Before I'm finished, I'm going to spin that rotor again, just to make sure those rollers are seated all the way. Now I can check my tolerance again with my feeler gauge. Now it's feeling pretty snug on that side at about 2 o'clock. And 10 o'clock is feeling pretty good as well. We just want a light drag. We don't want it to be a lot of pressure in there trying to go with the feeler gauge. And if you're unsure of yourself, you can do what I call it as a go, no go check. You can take the next size up, would be a 4/1000ths, and see if it fits in between the bearing race. Right now it's very snug. I can't even get it really to go down to the 10 o'clock position. If I go to 2 o'clock, I can't even get it in there. So that tells me I'm roughly between 3 and 4/1000ths, which is exactly where I want to be. Now that we have our bearing and our sleeve nut to the proper tolerance, we have to push down the locking tab on this washer. So what we want to do is we want to find a spot on here that lines up close to that tab. We never want to loosen that nut to get to a locking tab in position. So what we'll do is I'll spin the rotor and I'll find one that's close. So I'm going to find a tab that lines up with from the washer that will line up with this notch. This one here is about as close as I'm going to get. So I will tighten that up to that point. Now that I have the tab from the washer lined up with the notch on the nut, I can lock that down. This is a must. Be very aware of doing this. Do not ever forget it. Now that is locked down. Again, before I would finish anything, I would double check that the rotor is centered in the shaft and the machine is, and we're good at that point. Now we can grease it and put our bearing cap on. Now that we have our bearing installed, it's time to grease it. And on a new 3 15/16 bearing, it'll take 2 tubes of grease. So I will just take a simple utility knife, take it and cut the tube in half. Works about the easiest. And then you can just peel it open. Now that it's peeled open, you can just scoop it into the bearing cap. When packing the bearing cap, make sure you get it into the grooves. You need to get grease in all these grooves on here. That's how it keeps dirt out of the bearing itself. Now that the cap is ready, I can put grease in the bottom part of the housing itself now. So I try to get into all 4 corners. This grease is designed to melt, so you do not have to roll it and get it into every groove of that bearing itself. You try to get it into the corners, and that will go to the bottom of the housing. You want to get the seals on the rotor shaft as well. Get those grooves. Now we have our 2 tubes of grease between the cap and the base of the bearing housing itself. Now we can clean this little bit of grease off the sides and bolt the cap on. We'll take our cap and we'll slide it on to the top of the housing, and we're good to go. We'll take 2 bolts on each side of that housing and we'll put that through. When we're torquing down on a 3 15/16 bearing, it's 250 foot-pounds. Another thing to remember when we go and we're ready to fire up and run the machine, after you've installed all of your guards, removed all your lockout, tag out, you're going to want to check the temperature of this bearing. Normal operating temperature on a bearing, especially after an install, I would check it every 15 minutes. 140 to 180 degrees is a normal operating temperature. If you hit 200 degrees, stop, check and see what's wrong. Possibly take out some grease if you have too much added into the bearing. For any additional questions, please contact your Rotochopper support team. And remember, a well-maintained machine is safer and more profitable. Thank you for choosing Rotochopper for your grinding solutions. Remember to subscribe to our YouTube channel for more videos like this.